So this is going to be question number 5 on the discussion number 6, the one we didn't go over. But yeah, so the function is going to be prune small. And so what prune small is going to do, it's going to like take in a tree T and then a number n, and n is going to say like how many branches at most can we have in each like tree. And so if the tree has more than n branches, then we should be taking away some of the branches. And the branches that we should be taking out are the ones with the smallest, the ones with the larger labels. So we want to keep the n most smallest labels, the n branches with the smallest labels, and for the other branches whose labels are larger, we want to like remove them from the tree. And so if we look at the dog test right here, what we have is t1 equals like tree of 6. Actually, let's skip to this dog test at the very bottom because this is like a pretty big example. But t3 equals this huge tree, and I drew it on the right side, so this little tree right here. And what happens is that we call prune small on this tree, which is t3, and we say we can have at most 2 branches. And then if we check what t3 is, then we notice that it becomes the thing on the right. So as you can see, some of the branches got pruned. And so one thing to note about this function before we like look into what happens is that notice how we say like define t3 equals like some tree. You're going to see that for every tree problem. But what happens after is that we call prune small of t3 without like reassigning it to anything. And then if we check what t3 is, we notice that it's changed. And so what's special about this is that we know that prune small is going to mutate the tree. And so we can see t3, we assign it to a tree, and then nothing gets reassigned. T3 doesn't point to like a new tree or anything. But when we check what t3 is now, we notice that it's a brand new tree, and so that indicates that we should be mutating the tree rather than creating a new one. And so yeah, let's get started. And so looking at what happens here, we notice 6, it has like 3 different branches. And so 1, 3, 5. Let's not care about the children right now, because for the 6 at the moment, for the entire tree at the moment, we don't really care about the bottom ones. But we notice that there are 3 branches, and that's more than n, which is 2, when we call like prune small of t3 and 2. And so we're going to find out which 2 branches are the smallest. And as a matter of fact, we just want to like remove the largest one. And so if we see right here, the 5 is the largest one, so we're going to like essentially remove that branch, and it's not going to be in our tree anymore. And in addition, we also need to check like the sub branches. And so we see right here, there's in this 3 branch, actually let's start with the 1 branch. In this 1 tree right here, we notice that there are no branches because it's a leaf, and so we can kind of just like do nothing right there. But then if we look at the 3 branch in the very middle, we notice, hey, it has 3 branches, so we need to cut one out, and we want to cut out the larger one. And so in this case, it would be this branch right here, so we're gonna put an X right there. And then we don't really need to care about this branch right here because it's already been cut out from like this X right here. If we cut out like the parent node, the children aren't going to be in that new tree. And so what we end up with is this tree right here without the 5 branch and without like the 3 thing right there. But yeah, so let's think about how we want to like solve this problem. Let's not look at the skeleton code yet. Actually, you can take a look, get an idea of like what we might have. But what's going to happen is that, as I mentioned like in discussion, what I usually like to do, I like to imagine, what if I call prune small on each of like the sub branches, like each of the branches of the tree? Because typically with any like tree problem, you're always going to see like for b in t dot branches, we're going to like call a recursive function on each of the branches and something happens. And so let's think about what happens when we call prune small on each branch. And then 6, okay, I'm going to redraw the entire thing. Give me 1 sec, but you can like think about what might happen when you do it. And so what happens here, we call prune small on this branch right here. Yeah, actually take a minute, think about what's going to happen, and then we'll like come back to this. But yeah, pause, take a moment, and let's get started. And so here, for this branch right here, the 1 branch, it doesn't have any branches, so prune small of that tree doesn't really do anything. And so we move on. The tree is not going to change at all. So everything is as it is before. On the other hand, if we call prune small on this 3 tree right here, we see that there's another branch right here, as we talked about earlier, and so we're going to end up removing that 3 from that tree. And then for the 5 branch, everything's okay. We have 2 branches, and so that doesn't like violate anything. We don't have more than n branches, and so the 5 branch is going to stay the same. So we're going to end up with this result. And then so we made a recursive call on each of the branches, but how do we get to this result? Well, remember that with true recursion, you usually only want to handle stuff at like the certain like node, like the top node of the tree. You don't want to go down into the branches. And so notice how prune small takes care of like removing the extra like branches of each like sub branch of the 1, the 3, and the 5, and calling like prune small each of the branches. But for the current tree at the very top, we need to like eliminate branches if there are more than 2. And so here we notice that there's a 5 right here. There are 3 branches, and so we need to remove one of them. And so here we're going to be removing the 5, and that's how we're going to get our result. So to like reiterate over what I just said, prune small called on each of the branches is going to handle like the children's nodes. And if you might imagine, if that 1 sprouted into like 4 children, I would be like taking 2 of them out, and calling it on 3 took out that value 3, and then calling it on the 5 tree didn't do anything because everything was okay. And then after I made all the recursive calls, everything below the branches and below have been pruned, but we need to like prune the first layer of branches, and it's like this set right here. And so what we're gonna do, we're gonna like end up removing the larger values. In this case, it was the 5. But yeah, this drawing is a bit messy, so I'm gonna like erase it. But yeah, so what's gonna happen with our like pseudocode in like English of what's gonna happen is that for branches of T, and notice that the branches of T are like the top layer, so not like the bottom layers. We're not gonna care about that until our recursive calls. And so for our top layers, for the branches of T, if we have more than n branches, we want to keep removing a branch until we have n left. And as a matter of fact, the branch that we're going to be removing is the largest one, because if you imagine, we remove the largest one each time, and then after we have n branches left, these n branches are going to be like the smallest, like the n smallest branches, and those are the ones that we want to keep. And then afterwards, we're going to call prune small on each branch. And as I mentioned before, prune small of each branch is going to take care of like the bottom branches, like the branches further than like def 1. And so it's going to take care of that, and then we should be good to go after it. And I think I indented this a little bit. Shouldn't be indented. We're not doing it for like each branch. We're doing it for the entire list of branches, but yeah, you can ignore that. But yeah, let's get started. And so looking at our skeleton code, we have a while something, and then here we have a largest equals max of something. And notice how we have like a key. And remember that for max, a key function is kind of like a score function that you can pass in, and it's gonna give you the max element according of some like list, some iterable, according to that key value, that score function. And then we have a line underneath. Think about what that might do. And then we have a for something and something, and then we have one line underneath. And so that was like a lot of like some things, but take a minute or two, like think about like what you might want to do with the while loop, what you might want to do with the for loop, and then we like reconvene. But yeah, let's get started. And so one of the things that we want to note is that for each branch, we want to be making a recursive call. And as I mentioned like early in discussion, you're always going to see like something like for b in t.branches, and we're going to make a recursive call on that branch. and you might do some additional stuff with the branches, but in the case of this problem, you won't. And so as a matter of fact, what we want to do with our code is that we want to prune each of the smaller branches. And what function takes care of that is going to be prune small. And then so we have one for loop, so let's use that. And so we're going to go for b in t.branches. We're going to say prune small of b. And if we like look at our right side, what's going to happen is that reiterating over what's going to happen, we're going to go to the 1 branch, we're going to like prune it, we're going to go to the 3 branch and prune it, and since it had that extra branch, we're going to get rid of it. And then for the 5, everything's okay, and so it's going to prune all of like the lower layers of the tree. And so we got that down, and now we need to take care of like this first layer up here once again. And so how are we going to do that? Well, remember that we wanted to keep on removing branches until we have n branches left. And so that's what our while loop is going to be for. And so we're going to say while length of the t brought length of the branches, so t.branches is greater than n. So while we have more branches than we need, we're going to prune them. And so remember that we want to remove the largest each time. And so how do we get the largest? Well, we have a max function right here. And then so remember that we're trying to get the max of all the branches. And so that indicates that we should be passing in t.branches right here. But we need to provide like a scoring function to like get the maximum branch. Because if we pass in like tree objects, max is going to go like, oh, you're giving us objects, we don't really know how to compare them. And so we need to pass in a score function. And a score function is, the key function is going to be a function that takes in like one variable, and it's going to output like a score value. And so in this case, the elements that we want to go over are trees. And so the key function should be taken in a tree. So I'm going to call it like lambda t maybe. And then what do we want, like what are we scoring it by? And so remember that we wanted to score it by the label essentially. And so we're going to get the largest label, the tree corresponding to the largest label, and we're going to remove it. And so it's going to be lambda t.label. So we're getting the label out of it and we're returning it. And that's our score. And so largest is going to be the largest branch, the branch that has the largest label. And then what do we want to do with it? We want to remove it. And so recalling your like list mutation methods, the most convenient one in here would be the list.remove function. And so the list.remove function is going to take in like an element of a list. So here t.branches is our list, and we're going to remove the largest branch. And so the largest branch is, it might be like tree of 1. In this case, up here, it would be like the tree of 5 and like the children, the 5 tree. And then if we call like t.branches the remove of that largest tree, it should get rid of it for us. And if you might imagine, if we had more and more branches, it's going to remove the largest, the second largest, and all the way down until we get until we prune all of the branches down to n left. But yeah, this should be all the code. And once again, if you have any questions, feel free to like send me an email. I'll like write it down right here maybe. pow123@berkeley.edu. But yeah, send me an email if you have any questions. But yeah, hope you have a great night or day or whatever. Bye bye.